In the previous video, we talked about our subatomic particles and how we have discovered protons, neutrons, and electrons within our atoms. And atoms are indeed divisible. Okay, this video is going to talk about the evolution of the structure of the atoms and how they thought protons, neutrons, and electrons were actually arranged. Well, J.J. Thomson, who discovered the electron, came up with his own model, and it was called the Plum Pudding Model. And most Americans are like, what is plum pudding? Well, it's this thing right here, all right? It's basically a baked treat, um, and it's kind of like figgy pudding where there's just plums randomly stuck all throughout the cake here, and there's like a treat over top and all that kind of stuff. We're talking like Charles Dickens, 1700s, 1800s time. All right, so what he thought is that the electrons are spread evenly and randomly throughout. So the electrons would be these little plums in here, just randomly strewn all throughout all our pudding. And then the pudding part would just be positive material because he knew that there had to be some sort of positive material because if he held up the magnet to the uncharged gas, they wouldn't attract or repel. So, what I like to call this is my mint chocolate chip ice cream model. We've all seen mint chocolate chip ice cream. All right, so the ice cream part would be the positive material. They didn't know about protons just yet. And the chip part would be the electrons. So this random assortment of these electrons all throughout, and then just positive matter. And there wasn't, just on the surface like sprinkles or jimmies, but it was just randomly strewn all throughout. Okay, so this was the working concept of what we had on. And then a New Zealand scientist by the name of Ernest Rutherford in 1911, which is before the discovery of the proton, he figured out that there is a nucleus that is positively charged. And his famous experiment is called the gold foil experiment. And what he did is he worked with a radioactive source that had alpha particles, and he was shooting at really thin pieces of gold foil. And gold is really dense. You can get the foil really, really thin. And he put a fluorescent screen all the way around it to record the information. Now, alpha particles are invisible to the naked eye. So what he found is, okay, I totally expect to see all of these particles on the other side. He did, except for every so often there was this random deflection in another place. Well, one of the things that we haven't learned yet, but we will in the atomic nuclear chapter, is that alpha particles are positively charged. So what was here that was positive that could cause this to repel? So he came up with this concept of having a positive nucleus in the center, and the electrons are randomly strewn around. So this updated and changed J.J. Thomson's plum pudding model. All right, so here we have another depiction of this, and it's just flipped in the other direction. But what I really like it for is this section right here, because if you really zoom in on the alpha particles, you'll see, or on the gold foil, you'll see that these alpha particles mainly go straight through. Okay, so they go straight through until they get really close to this nucleus, which is positively charged, and then they deflect. Sometimes they can hit it straight on and come and deflect all the way back. So he found that this nucleus was really small. It happened every 1 out of 8,000 or so alpha particles. In class, I show you a video of Rutherford's experiment, and they show like this animation of the whole thing, and I show you the BBC people pretending to be alpha particles, which is a hilarious video of kids in their basement and a mattress named Fluffy. There's links on in the notes and on my website to see, so you can view that on your own. But this gold foil experiment is really vital because it changed everything with the concept of how protons, neutrons, and electrons were all arranged. So these deflected particles were a really, really big deal. Okay, so the alpha particles, like I said, are positively charged and like things repel. So there had to be some sort of dense, positively charged center. And I would definitely star circle highlight that because that is the key concept for what we have um, with our nucleus here. Dense, positively charged center of our nucleus. And the nucleus is going to be surrounded, at this point, we just know about an electron cloud, and we'll get to that in subsequent chapters also. So every once in a while, every 1 out of 8,000 alpha particles was deflected. So he can figure out it was really, really small. Okay, and to quote Rutherford, it was as if you fired a 15-inch artillery shell, which is like a cannonball, at a piece of tissue paper, and it came back and it hit you. All right, so with a scale, this is our Schwarzman Stadium here at Abington. If the nucleus were a marble, the atom where the electron cloud would be the size of the football field. Okay, so there you have your little dot in there. Ooh, I don't even know if, let's see if I can try to make this smaller yet. You have your little dot, and if you think about these alpha particles and everything going through, okay, you would be able to cross the field about 8,000 times before you were to blindly step on the alpha particle, step on the nucleus or the marble in the middle. So bonkers crazy how small it is, but we do have a very small, positively charged, dense nucleus.